In this video, I will show how you can use Simulink FMU Builder to create and simulate an FMU from your Simulink model. Specifically, I will highlight Simulink FMU Builder's support for cross-platform compilation. Functional Mockup Units, or FMUs, are zip files that adhere to a standard that is supported in over 270 simulation tools. This makes collaboration across different modeling and simulation frameworks simple. FMUs are exported with operating system-specific shared libraries for Windows and Linux. Normally, you would have to ensure compatibility between the package binary and the system importing the FMU. However, with the cross-platform support of Simulink FMU Builder, this consideration is no longer an issue. Simulink can export both binaries and even simulate a Linux shared object on Windows. I will now show you just how easy Simulink FMU Builder is to use. Say we want to take this model of a fuel rate control system and send our plant model to a colleague who uses a different simulation environment which is not necessarily Simulink. First, let's open up our plant model. To get the process started, click Save As and select the Standalone FMU option. This will open our UI that walks through all the steps of building your FMU. Here we can choose if we want to build an FMU for model exchange or co-simulation. The main difference between these two options is that an FMU for co-simulation has the solver packaged in with it, while an FMU for model exchange relies on the solver of the importing tool. For our purposes, we will stick with co-simulation. Next, we can customize the parameters, inputs, and outputs of the model. In this next page, we can change the name of our FMU, the save directory, and other important parameters of the FMU. Now we are going to select this checkbox to generate the Linux binary. This will allow our colleagues to simulate our model on a Linux system despite being exported from a Windows computer. As you can see, there are also plenty of other capabilities we can enable, such as generating code for embedded systems or packaging in a constant periodic clock. You can also include any additional files you want within your FMU. Finally, we can review all the settings and build the FMU. Now that we have our FMU built, we can change the file extension to look under the hood. Here you can clearly see both a Windows and Linux binary included. Now let's delete the Windows binary to show what we could do if our colleague sent an FMU they exported from a Linux machine with software that doesn't support cross-platform compatibility. If we reopen our original top model, we can replace our model reference block with the FMU we generated. After selecting the correct file within the block, we can ensure that Simulink will look for that SO Linux binary in the Simulation tab. Since we deleted the Windows binary, it should be the only option. Now we can run our model, open up the Simulation Data Inspector, and compare our new results to a previous run. Looking at our fuel signal, you can see that the FMU is able to simulate the same results as the original model with no issues from using the Linux binary. You've seen how easy Simulink FMU Builder makes sharing your model across simulation tools without having to worry about which operating system the model is running on. If you would like to learn more about Simulink FMU Builder, please check out the documentation page on mathworks.com/help/FMU export. Here you can find detailed documentation for supported capabilities and examples of different FMU workflows.